Hi, this is our Geomon presentation. So at first our idea was with combining Pokemon Go and old school Pokemon. We have features like Pokemon style turn-based system, Google Map and tracking system, and monsters and items. Later we decided to add some new features like multiplayer AI chat that we successfully added, but then we didn't have enough time to add hatching monsters and gacha loot box system. The reason that idea was worth approaching is that knowledge learned in class, like Google Map tracking system database, can be applied. Let our team explore more interesting features like Gacha AI chatbot. With multiple features, workload can be distributed easily between team members, and also this has some interesting battle system, including like elements, level, move stats. So Brandon did JSON repository thread link like adding moves and monster stats in a JSON file and parse it into the Room database. Pokemon turn-based battle system, item bag, Geomon inventory, and stat screen. Long did assist with Google Map implementation and merging code. Monster spawning, adding monster and sprites, and AI chatbot, and also name and avatar change settings. Ming did a tracking system, PvP system, merging and resolving Git conflict. Also Firebase implementation like players, monster states, etc. He also assisted with monster spawning and player directional sprites. While Zhang only did the UI main activity bottom bar, and Daniel did nothing. Here are some challenges that we faced during our project. The first one is refactoring from only room database to Firebase plus room database, which is basically refactoring from single player to multiplayer. Also, the battle system was pretty complicated, especially in PvP. The UI refactoring was also very challenging because we have to change from navigation view to like tab system where you press the button, it changes the activity. Also, the most challenging part was Git merging and resolving conflicts because we didn't know how to properly use Git. So Ming has to go out his way to teach us how to create branch and merge code. So that's three lessons that we learned from doing this project is that we have to create a branch on Git if any members want to implement a new features and merge the code after. We should not push on main. And we should also set like documents explaining how our features work whenever like you implemented it and push it onto Git, so that the other members don't have to like read it and like try to understand it for a few hours. Also, do not push API keys to Git.
Hello, this is the demo part of the app. On launch, the player sees the nearby map that has spawns of a variety of different items and monster objects on the map. These change as the player moves and walks on the live map. To change your name, tap on the top right expandable menu and click Change Display Name, and you can change the name to anything that you want. It saves it and updates it on the main menu. Change your avatar by tapping the bottom left profile picture and clicking the Change button. This will allow you to select a photo from your files and upload it to the database. When we tap a monster on the map, we open the counter screen. From here, the player can choose to fight or exit the counter. Upon selecting the Fight button, the map fragment passes both the starter player monster ID and the map's enemy monster ID through the intent extras. When starting the activity, both IDs search through our database and loads all the moves. To display and use the moves will also use the database information. In the battle activity, you have the option to catch or utilize your 4 different moves as displayed on the UI below. When inputting a move, a turn is initiated which monster has the fastest speed in their stat, which is from the database. The fastest speed will attack first. There's also a type chart for move effectiveness, such as rock being super effective on fire. The enemy is a fire type as noted by the name called Embercrest, and I have a rock type move on my UI. So if I click the rock move, this will be super effective and will display on the UI. Since it was super effective, I won the fight. It displays that the enemy faints and brings me back to the map activity. To catch an enemy, I would want to use a weaker attacks to weaken the enemy monster to allow a better catch rate. For example, if I want to catch this Mo Diver on the map, I will click on it and fight it. To capture it, I would use a worse move that's not very effective on ground types. Mo Diver is a ground type, and Rock is not very effective on ground, so I would use the Rock type move. This will not one-shot it, which will allow me to capture it and add it to my user's list that contains all the monster IDs. To display all your monsters, tap on the bottom right-hand corner to display your Pokédex. The Pokédex activity takes the player's monsters objects list and searches the sprites to display, and the level and the HP that they have remaining. Upon clicking on one of your monsters, this starts as an activity that uses the monster's ID and takes all the stats, moves, sprite level, moveset, typing, and clearly displays them on my screen. To set your starting monster, tap the Set as Battle Monster button, which saves the monster's index to the user for the next battle. Your active monster is displayed in the user profile on the bottom right UI. To heal your monster, our map generates items that have different potions on the map, which you can tap. For example, I can tap these potion icons on the map, and they will be added to my bag list. Defeating monsters also rewards the players with items. For example, if I defeat this Embercrest monster and use a rock type move as it's super effective, I will get a randomized items as it's displayed on the Toast UI. They are placed in your item bag, and to use them, click on the item menu. This opens an item bag activity and shows all your recent items that you collected. To use an item, click on the item's icon, and this will open up all your monsters that are lower HP than their max HP. This will heal your monster's HP, and that will be saved back into the database. You can also heal your monsters by utilizing scrolls that you gain from defeating monsters. In your item bag, you can see that I have items called level up scrolls. When I tap on the scroll, I can tap on one of my monsters to level up. For example, I can level up my Modiver from 60 to 61. It shows it on the Toast UI. You can also talk to your monsters, which is up on the top right drop-down menu. It's called Monsters Chat. Each monster has a different personality and response. For example, ground-type monster called Modiver has a talking description that relates to ground, such as dig. I also can reply back, such as hello, and he will respond back with a very customizable response. One of our core innovations in our project is the multiplayer aspect. Multiple players can be seen on the Google Maps live and updates dynamically. They all display the user's icon position and what direction they're pointing at. More importantly, you can duel players by tapping their character on the map. When the other player accepts the duel, a battle will commence and whoever has the starting monster wins.
This means I will go over to the thread design. First off, all UI-related activities are displayed in the UI thread. There's also a tracking view model which receives the data sent by the location service through a message handler. For the background thread, we parse the species and skill data from the JSON file in the IO thread and add them to a room entity species database. We also use room to store a local database of item and skills. We also communicate with Firebase to fetch the Pokemon around the players, and if there are not enough Pokemon, we try to spawn them with random species. The items are just randomly generated on the map. Our monster data class is a middle interface to either initialize or fetch the monster data from Firebase and map them to a local monster data object. Our battle logics for fighting wild monster are mainly on the main thread, beside all the monster fetching and initialization operation. For the battle between the players, the communication happens through a Firebase battle state object, which will be explained later. Okay, so for Firebase, all the operation happen on some internal worker thread pool, and here we communicate with Firebase to apply the change of data to the monster and user object on the real-time database. We use Firebase anonymous authentication and to validate the user on each device and synchronize it with the user object in the real-time database. We also define a dual request and a battle state data class to facilitate the real-time battle between the multiple player. And beside those, we also use Firebase storage to upload the player avatar. Our location service uses GPS to track the player location and send the data to the tracking view model in the main thread. For multiplayer, we have a heartbeat system to constantly send new timestamp data to Firebase to notify the system that the player is online, and the listener on every open app to fetch the ID of the nearby online player and display them on the map. The dual system works by first a player sends a dual request to another player through a dual request data object on Firebase, and if the other player accepts, the battle activity will be launched on both devices and a new battle state object will be created on Firebase to facilitate the fight. And in the battle activity, there is a listener on both devices that listen to the same battle state on Firebase. Once the player makes a move, the change is applied locally before the battle state object is notified, and then the turn field change to the next player, and the listener apply all the change on that player's side. For the chatbot, we use Gemini API to let players talk to their active monster. The Gemini API class handles all the network communication on the IO thread.